हेलो एंड वेलकम अगेन टू फिजिक्स गैलेक्सी। सो कल एक और प्रॉब्लम आया था टीएफटी एग्जाम में इलेक्ट्रोडायनामिक्स के रिलेटेड, जिसमें हमारे पास चार्ज 5 चार्जेस गिवन थे। सो दिस वाज द चार्ज नंबर 1 2 3 4 एंड 5। सो 5 चार्जेस वर गिवन एंड हमको ये बताना था व्हाट इज फंक्शनल फॉर्म ऑफ पोटेंशियल। ओके, एंड द डिस्टेंस वर गिवन। सो दिस डिस्टेंस was a, this distance was a, so this distance was a, this distance was a, and this distance was also a. Okay, so to find the potential for these problems, so हम पहले क्या करना होता है, we have to find the total charge. Okay, q total. So q total, as we know, for this configuration will be q minus q. So ये actually minus q यहाँ पे q minus q minus q plus 2q minus q. So total charge is 0. Then so that means potential will not vary as 1 over r. Okay, because there is no monopole. So it will not vary as 1 over r. No monopole. Okay, so no monopole term. Then next comes total net dipole moment. If net dipole moment comes out to be non-zero, then that means it will have a dipolar characteristic. So that means v will be proportional to 1 over r square. So that is what we need to see. Okay, so for this configuration, as you can see, net dipole moment will be non-zero. How? Let's see. So let me draw it quickly here. So I have this kind of charges. So this is minus q minus q. So I have two q here, which I can write as q and q. Okay, and then I have minus q. So there are three dipoles. So one dipole I can make like this, because total charge is 0. So the dipole moment doesn't depend on the choice of origin. Okay, so I can take this as my first dipole, this as my second dipole, and this as my third dipole. Okay, remember the dipolar direction is from minus to plus. So three dipoles, and what will be the magnitude of this dipole? Suppose it will be because this distance is a, this distance is a, this will be root 2 qa, root 2 qa. Similarly, this dipole will be root 2 qa, and this dipole will be qa simply. Okay, right? So three dipoles we have, and because we know they are they have not, their net dipole moment is not 0. So let's try to find the p net. P net. So P net is, because we have two dipoles in this direction. So one dipole in the same direction, and one dipole in this direction. So let's calculate first the x component only. Okay, x component only. Then I will calculate the y component. So x component will be this and this दोनों का x component. So that will be 2 times x component किसके बराबर होगा? So root 2 qa cos of 45, that will be 1 by root 2. So this is the x component for these two, right? And इसका x component कितना होगा? Minus qa, right? So x component निकाला हमने. Then what about the y component? Y component इसका तो 0 होगा. So only इसका और इसका y component निकलेगा. So that will be 2 root 2 qa cos of 45, that will be 1 by root 2. Right, so it will become root 2 cancels out, root 2 cancels out. So p net जो हमारे पास आएगा, that will be q a times x cap plus 2 q a y cap. So this is our p net. Okay, so अगर हमारे पास net dipole moment निकला, then we can calculate the potential for the dipole, because we know v is given by p cos of theta divided by 4 pi epsilon naught r square, or we can write it as p dot r vector divided by 4 pi epsilon naught r cube. Okay, let me write this as fancy r. Okay, so we know now what is p. So p is here. So let's substitute here and we'll get the final answer. So v will be given by 1 by 4 pi epsilon naught r cube. Okay, so we make qa common here, so I will take it out. Qa, then it is x cap plus y cap dotted with r vector, so which equals to q times a divided by 4 pi epsilon naught r cube x, सॉरी यहाँ पे 2y था, 2y x cap dot r vector plus 2y cap dot r vector. So this was the answer.